Okay, in this presentation we are looking at information theory, and essentially what we're doing here is dovetailing with probability stuff that we should have seen before. So the frequency of a zero signal to a binary channel is 0.6, okay? And if 0 is the input, then 0 is the output with a probability of 0.8. So that's the output conditional on the input. Just be careful of that. So if 1 is the input, then 1 is the output with a probability of 0.9. So here's the questions we're asked. Calculate the probability that the output is 1. Calculate the probability that the output is 0. Calculate the probability that the input is 1 given that the output is 1. That's not what we're given above. It's the opposite. That's the input conditional on the output. What we're told up above here is the output conditional on the input. And the fourth question is calculate the probability that the input is 0 given that the output is 0. Okay? So this is particularly awkward in terms of stating our notation. Okay, ones and zeros everywhere. So I have 4 events here. Let IU be the event that the input is 1. So here I for input and U for U rather than 0 or O for 1. Okay, U for unity, U for uno. Okay, and OU let that be the event that the output is 1. Okay, here O for output. Okay, let IZ be the event that the input is 0, Z for 0, and let OZ be the event that the output is 0. Okay, a little bit awkward looking, but essentially if you're familiar enough with U and Z as standing in for 0 and 1, and I and O standing in for input and output, then we're good to go. That's just actually sort of what's sort of very peculiar about these videos. I, O, and 1, 0 are control you a little bit, and really actually, if to be perfectly honest, that sort of system of naming things with U and Z and I and O is actually helpful. Okay, now we're told that the probability of an input of 0 is 0.6, and that means the probability of an input of 1 IU is 0.4. Okay, so that's what we're told in the question. We're also given some conditional probabilities here. That the probability of an output of 0 given that the input was 0 is 0.8, and we were also told that the probability of an output of 1 given that the input was 1 is 0.9. So necessarily we have these two complementary conditional probabilities. The probability of output being 1 given that the input was 0 is 0.2, and the probability of output being 0 given that the input was 1 is 0.1. Okay, so that's also quite helpful. And in fact, I think really actually we sort of tackled the question fairly well already. So calculate the probability that the output is 1. So the probability that the output is 1 is the probability that the output was 1 given that the input being 1 plus the probability of the output being 1 and the input being 0. Okay, so that essentially what we do is create these expressions. We restate them in terms of conditional probabilities. Okay, and so the probability of OU intersection IU is the probability of OU given IU times the probability of IU, and the probability of OU intersection IZ is the probability of OU given IZ times the probability of IZ. That is just restating the conditional probability formula and rearranging it accordingly. So when we work out those values there, we get 0.9 times 0.4 plus 0.2 times 0.6, and that works out to be 0.36 plus 0.12, 0.48. Now necessarily that means that the probability that the output is 1 is 0.48, and we can immediately tell that the probability of the output being 0 is 0.52. We weren't asked for that, but that's something we should spot immediately. Okay, now that's going to help us, but what I'm going to do is actually just test this straight away. Okay, so we actually sort of know our answer already, but I just decided to just reconfirm it here. So the probability of output 0 is the probability of an output 0 and input is 1. Okay, That's what I have here, and the probability of, plus the probability output 0 and input 0. Okay, so using the conditional probability formulas there, we can express the probability of OZ, and IU as probability of OZ given IU times the probability of IU, and likewise probability of OZ given IZ times the probability of IZ. That works out to be, again, using the numbers that were given in the question, 0.14 times 0.1 times 0.1 times 0.4, and 0.8 times 0.6. Okay, and that does work out to be 0.52 as we supposed. Now, so the third question here asks us the probability of the input being 1 given that the output was 1. Okay, we were not told this in the question, but this is what we were told in the question. Okay, the probability of the output being 1 given that the input was 1. That was 0.9. Okay, we also know that the probability of the input being 1 is 0.4. So altogether, this the top of the expression works out to be 0.36. The probability of the output being 1 is 0.48. Okay, so that means 0.36 divided by 0.48. That is 0.75. And necessarily, the probability the input was 0 given that the output was 1 was 0.25. Okay, and again, use the Bayes theorem formula here again. Okay, use Bayes theorem to show that, or solve this. We're asked for the probability that the input was 0 given that the output was 0. Okay, so that is the probability of the output being 0 given the input was 0 times the probability of the input being 0 divided by the probability of the output being 0. Okay, this is Bayes theorem, which is essentially an extension of the conditional probability formula. So that works out to be 0.48, the top part of the expression there, 0.8 times 0.6. And again, that's just what we were told in the question at the start. Okay, working that out. We know that the probability of O0, or output being 0, is 0.52. So essentially we end up with 0.48 divided by 0.52, which is 0.923. Okay. Just as a remark, we weren't really asked for this, but the probability that the input was 1 given that the output was 0 is 0.077. Okay, it's always actually useful to look at these complements. Okay, you can save yourself a lot of work by just thinking about what the complement of a probability is or what it means. Okay, that's a great way to get the hang of probability questions. Is actually just that's always the secret key is the complement of the event. Okay, all right, we'll leave that there.